onto the x-axis, right? If we did that by integration, you guys remember all of this? What would we do? It's an integral from a to b of f of x, and in this case it'd be minus 0, but minus whatever your bottom was, dx, right? So now if I want to find this area in polar form, it's a little bit different because we don't move left to right in polar. We move out from the origin. Remember, we sweep out as we go along. All of those little things we're going to add up. These are called sectors. So like this little guy would be a sector. Okay? So you're going to add up all of those little sectors together, just like you'd add up all of these rectangles, remember? Okay, so we're adding up all of these sectors to get to the area inside of a polar curve. Is that okay? So if you want to kind of think back, area of a sector of a circle, anybody remember that? What's that? Okay, so 1/2 is, so when we're going to do this integration, we're going to have 1/2 our r theta squared. So you're right with the 1/2. Okay. And then we're going to go from like alpha to beta. So like a to b because they're angles. So we can label those alpha to beta. And we're in a function of theta, so d theta. Okay. So how that corresponds to the area of the sector. So we have 1/2 r squared theta. It's very, very similar. We're going to have this function of theta squared. Kind of think through. Okay. And our alpha is being taken care of, or sorry, our theta is being taken care of from alpha to beta, basically. You're adding up all of those. Okay. What we talked about. You just want to kind of see why it's all going on. Alright, so here we have that area formula that we just talked about. So let's find this one. So let's find the area of the region bounded by this graph of the luminescent. R squared equals 2 cosine theta. The origin and between the rays, theta equals negative pi over 6, so theta equals pi over 4. So if you wanted to try to graph this, you could as well. If you wanted to put it in your calculator, what would you have to do with that r squared? Square root. So if you want to go ahead and try that in your calculator so you can kind of see. So in our, like the first one, we're going to have the positive. And then the second one, we're going to get the negative. And if you wanted to put thetas in as well, you could do that. So normally whenever you have an r squared equaling, you're going to get out that like infinity shape, okay? So again, if you want to zoom in and see better. Is that or something? Yeah, you're in phase. Okay, so we have our square. Do I square this guy? No, because I want r squared to go in there, and I already know what r squared equals. Okay? So now go do that by hand. I'll put up the answer that you should get out. Everybody get that okay? One sec. What plus? Yeah. Anybody need more time on that? Okay, so that's as basic as you could get it, right? And this one even had the graph all provided for you. Not always the case. So here, let's look at this. Find the area of one petal for this guy going on, and don't pay attention to those ones. That was just me trying to find a graph really quick. Okay, so these are. All right, so let's think about this guy. How do you first off, well, it tells you one petal, so you know it's a rose, right? And then did anybody start looking over the page 690? Grr. So if this is even, what happens? If this is an even number, then you have 2 times whatever that number is petals. You double that number. If it's an odd number, then you have just the odd number of petals. Okay, so I know I'm going to have 4 petals. What are the lengths of the petals going to be? Okay. So you have a length of 6 going on. So you know right here, this length from here to here is how long? 6. Well, how did you know, though, it goes like in those areas versus, you know, on something like this? Okay. So you could also, if you weren't quite sure, if you didn't remember everything, then you could make your R theta chart. So let's pick some. Let's start at 0. And what do we get out? 0. Okay, so I'm right there. Let's go to pi over 4. And what do we get out? 6. So right there I can see that I'm going to have my petals going this way as well. Right? Did you find your possible tangents at the pole? So we could say 6 sine 2 theta equals 0. Let's find those possible tangents at the pole to help with my graph. So where does sine 2 theta equals 0? So I'm looking where 2 theta equals what? 0, pi, 2 pi. So where theta equals 0, pi over 2, pi, which is all going to repeat now, right? So I can see going on at 0 is the symmetry. This guy's the symmetry. Do I even care if there's tangents at the pole if they're helping with symmetry? Not unless I asked you, are there tangents at the pole? And then what would you have to check? If r prime also equals 0 there, right? Alright, so now that we have this sketch, it wants me to find the area of one petal. So what could I do here? Let's go to Tyler. first find the area of one petal, then we're going to find the area of all petals. Okay? So let's first find one, and then whatever we get, we would multiply by 4, yes. So this one, you could have done it either way. You could have went twice from 0 to pi over 4, or you could have left it 0 to pi over 2 and multiplied by half. Okay? Oh, okay, so let's go pi over 2 would be where? Plug it in. 0, we already know, right? So we went, okay?
Why would you want to go to pi?
Because then you could double it and get rid of the half. Okay. So see what you get out for that. Okay. So you guys like going from 0 to pi over 2? So you don't have to deal with pi over 4s? I'm fine with that. Ooh, what do we have to do with a sine squared? It's a formula we used all the time in chapter 7. See if you can remember in your group what you're going to do. Now put up your final answer for one petal. See if you can get to that. Just kidding. Sorry. So what does sine squared become? 1 minus cosine, and we have to double. If we had a 2, now it becomes a 4 theta over 2. Did everybody get that part? And if it was a cosine squared, it would be 1 plus. make it negative, add it to the top, and then you get out 0. Okay? So that's why you want to use symmetries a lot in polar. Are you ready one more time for this one? All right. See if you can start the next one. Once you find the area of the inner loop, it's already giving you a hint. So can you get the graph? See if you can get the graph going. Sketch what it's asking you to find. So sketch what it's asking you to find. So you can always find possible tangens at the pole. It's telling you there's an inner loop. You can make an arc theta chart. Yeah, but it's a hard loop. Go look over it. Do that. No. Go on the next. So make sure you don't make it too skinny. Try to approximate a little bit how far you're going to be going out. make our theta chart okay? Did everybody find the possible tangents at the pole okay? Tyler?
So like on a problem like this, is we expected to know, or I guess it says it's literally, but like I was just thinking, like if I saw that, like if I made that chart, I probably wouldn't make it.
So let's start there. Let's see. Here's where theta is 0, right? Then I'm moving at pi over 4. I moved right to here, right? Okay, and then let's see, at pi over 2, I'm right here. Let's see. At pi, I am at -2. Well, here I am at 2 pi over 3. I'm at 0, right? I'm going this way. And then at pi, I'm right here. And then at 4 pi over 3, I'm back at 0. And then we could see at 3 pi over 2, I'm at 2. And then you can put in 2 pi again to be back where you started. And you could get some more if you wanted in here, but you could think of symmetry. Okay? So I know if that's a point, then I gotta make it symmetric as a point. Does that help?
Yeah.
So that's why it's important to kind of follow along what you're doing, especially for this, to know the direction that you're moving. Okay? That's going to be pretty important here. What do you guys think so far? Is this tough? Okay. So I have a whole other worksheet we're going to be doing with 9.5 too, okay? So you don't get stressed out. Alright, so then once we're here, it wants me to find the area of the inner loop. Okay? Does everybody understand this so far, the graph? Or are there questions about that? Okay, so the area of the inner loop. And again, if I can use symmetries, find half the loop and then double it. It might be a little bit easier. So let's see, I know that the loop starts at 2 pi over 3 and it ends where? 4 pi over 3. So I could go from 2 pi over 3 to pi. That's why I like to label as I go along. So I know what that value of theta was, okay, as I'm doing these. So I could go from 2 pi over 3 to pi and then double it. Or I could go from pi to 4 pi over 3 and double it. So remember, you're getting sectors sweeping out, right? So if I went from 2 pi over 3 to pi, I'm getting all of those sectors sweeping out. Is that okay? Lane? Alright, so, or you could go from pi to 4 pi over 3. Set up your integral now. So let's double our formula of 1/2, what do you guys want to go from? 2 pi over 3 to pi of r squared d theta. So now I've got rid of that, which is nice. It's when I doubled it, right? Square it out. I feel like you guys need the practice of doing this one by hand one more time. So let's go ahead and do that.
It's super quiet today.
I'll put up the answers if you're going to get to it. after this one, for these next couple, I'm going to let you use your calculator. Stay on time. You got it right, and people can't figure out where they're making their mistakes. Help out. from 2 pi over 3 to pi. Did you get that? Okay, I'm going to need to move on. If you're still stuck with integration, we can work on those skills again later, okay? Oops. So, get the next one. Find the area between the loops. So they're telling you got a loop again. So get this next one sketched. I want you to sketch it by hand. I'm going to let you just put it in your answer on the calculator, but this could definitely be a by hand one. We're just going to save some time. you do with the switch? Oh, I know. That's 7 times 6. So 7 pi over 6 is right after 5. Oh, this one's one. That's where you found one. Yes. You still want to, yeah, you still want to apply in those ones. Like if I was to put right here, 7 pi over 6, what would you get out? 0. Okay, so then you're right there. You got a 3 pi over 2, which was negative 2. And then 11 pi over 6, which was 0. Okay. And then you're back at 2 pi. You are at 2. Okay, so at 2 pi, you're back where you started in this case. Alright, so now that we have that, let's see what it asks for. It says find the area between these loops. So you are finding this area right here. Yes? Ideas. How can we find, because remember sectors are going to include everything out to like whatever theta you're at, right? So from 0 to 2 pi,
Or 0 from pi over 2 times 2.
well, you don't want to start at 0 because that's not going to go here, right? You got to get all, otherwise you're going to miss that little part. So where do you think you'd want to start? Negative pi over 6 to where? Could I go that half and then double? So all the way up to pi over 2. So that's going to give me the big area. And you can fill in r squared d theta. Okay. Then, so that's going to give me all of that area. And then I'm going to have to multiply it by 2. So that's included the loop. So to get rid of that loop, what am I going to have to do? Minus 7 pi over 6. So you're going from here to here. See why we labeled them? So we can go from 7 pi over 6 to where? 3 pi over 2. And we're going to have the 1/2 and double it. So you're going to get that area. So we're subtracting that out from the whole big area. And then we've doubled it for both sides to get the area between the loops. And you can put that one in the calculator.
So like on if this wasn't proper, you know, my calculator would be just right.
Right, because r's already, well, r's defined. You'd have to say what r squared is somewhere. Okay? So if you wrote r squared below it, then you'd be okay to go. Yes. So we have to take out this little area, right? And then, like, I doubled it. So I know that that 0 starts at 7 pi over 6, and that goes up to 3 pi over 2. So that's going to give you that area. And then if I double it, right here, or the doubling, then I can like get both sides. Or you could have went from 7 pi over 6 to 11 pi over 6. Make sure you always like go in order. The reason we said negative pi over 6 instead of 11 pi over 6 here is because you want to always go in order. Okay? A theta. Okay. So that's why in this case we could have went from 7 pi over 6 to 11 pi over 6 and not doubled it. Or we could have went from that 11 pi over 6 to that 3 pi over 2. And that's why I always like to put what my theta values are, so it's easier for me to reference when I set it up. I got. I'm going to put the last one answer. You can see if that's the same. No, I didn't. Because I use auto. Yes.
Why do you have to try to set pi over 6?
Because as you're moving along, you started here. 7 pi over 6, I'm right here. And then at 3 pi over 2, I'm right here. So now I've swept out that area. And then 11 pi over 6, I'm right here again. And then I'm back to where I started. So you could have went from 7 pi over 6 to 11 pi over 6 to get the whole loop. Or we said we could have went from 7 pi over 6 to 3 pi over 2 and doubled it. So if you want to put those in your chart, it might help you.
Yeah, that's why I was expecting.
Okay?
Why can you use pi over 6 because it's for also negative pi over 6?
Negative pi over 6, yes, but you want to go in order. So this 11 pi over 6 is negative pi over 6. But if I'm going, I have to go 7 pi over 6, the next thing is 11 pi over 6, not negative pi over 6. That would have went craziness. Okay? Alright. Yeah. I wanted to do one more today. Don't think it's going to happen. Okay. Okay. I will help you. We're going to have to do our 9-3 quiz. We're going to finish up the rest of these notes tomorrow. And also look over to turn in your 9-1 quiz. I'll randomly select, or 9-2 quiz. I'll randomly select as well. So if you don't have your homework done, you have your homework done for 9-3. Quickly.